to another video from Analyst Q. I hope you're doing well, especially in these challenging times. In the last few days, weeks, I've had a lot of time to work on some side projects, which is why you've seen so many posts about PubSub Plus Event Broker and how you can consume and publish messages to it from within your queue session. So KX recently released this API which allows you to interact with Solace PubSub Plus Event Broker, and it's a really powerful API which allows you to bring the power of PubSub Plus messaging into your KDB stack. So I've been working on a lot of demos and just playing around with the API. So I recently wrote a post about enabling a modern hybrid cloud KDB plus stack with PubSub Plus Event Broker, and it's actually an encompassing post about 3 different posts that I wrote. So it contains these 3 different components. The first one is a feed handler. So I wrote a post about market data simulator, how you can simulate market data prices for a handful of securities from different regions and publish that data to a PubSub Plus event broker. And this feed handler is written in Java. And then I have a separate stats process, analytics process, which is a QKDB process that is consuming this data and then doing something with it. So it's computing minutely stats, just the high, lows, prices and sizes, VWAP every minute, and then again pushing that those stats back to PubSub Plus. And then finally, I have a pipeline that I have written using Apache Beam and then deployed it on GCP's data flow, which is Apache Beam managed service. And then it is listening to that data that was published on the stats data that was published to the broker, and then consuming it and then writing it to BigQuery. So in this video, I would like to show you all of this, how it works together. So this is what the architecture looks like, and what I'm going to show you is I have my Java feed handler, my market data simulator. It is running on my laptop, so locally, and I also have a Solace PubSub Plus broker installed on my laptop through a Docker container. Then I have a separate Google Cloud deployment in AWS. Sorry, not Google Cloud. Solace Cloud deployment in AWS as well, and I have a QStats process running in AWS as well on an EC2 instance, which will be consuming data for only US securities from Solace, and then writing the stats back to the broker. Finally, my GCP pipeline, my Apache Beam pipeline, will be consuming that data from the same cloud instance of the PubSub Plus broker and then writing it to BigQuery. So there's a lot that's happening here, a lot of core PubSub Plus features that we are using to build this hybrid cloud KDB plus stack. So first of all, we are using rich topical hierarchy, which allows us to do wildcard filtering. So I will be publishing market data on rich hierarchical topics, and then I'll be filtering using Solace's wildcards to only select US data, right? Then we will be publishing that data, the stats that we computed using KDB, back to PubSub Plus, and then from there n number of subscribers can consume that data. So we're leveraging PubSub Plus messaging over here. Of course, right now we only have one consumer here, which is listening to this data, and we'll be writing it to BigQuery. Then we're taking advantage of Solid's event mesh feature, which is powered by something called dynamic message routing that allows you to link these brokers together without much configuration. It's a very dynamic self-healing connection that allows you to send data to one broker, and a different process can come up and subscribe to that data. And once it does that, only then the data will flow from your on-prem broker to your cloud broker or anywhere else that it might be. So you're not always replicating your data if there's no subscriber that has asked for it. So that saves you, networking costs, especially when you're working with cloud providers. It also is a much more secure way of doing things, because especially if you're dealing with sensitive data, you don't want to copy, to replicate all of that data from your on-prem to these public clouds, right? You only want to send the data that those subscribers are entitled to and have asked for. Finally, using an event broker or middleware layer allows you to integrate with a bunch of different processes. Because Solace supports open APIs and protocols, you can take data from KDB and write to these cloud native services such as GCP. And of course, you can go the other way around too. So it really opens up your KDB stack to all these new services that have popped up recently, especially the cloud native ones, and allows you to take advantage of them. So for example, you might want to take advantage of the AWS machine learning algorithms, right? All right. So let's look at what we have. So first of all, here's my Java feed handler. You can see that I'm connecting to my localhost 55555 port, default VPN. So if we just kick that off, okay, we're publishing data for different securities. So here you can see that we're publishing data for UK LSE, and the symbol is TED. And then we have data being published for a Singaporean security as well, DBS, Popular Bank, right? We have US data as well for Apple, US data again for Facebook. So basically, we're publishing data for different types of securities from different regions and exchanges. As you can see, locally, I have a Docker container running, which is my local Solace PubSub Plus instance. It's really easy to kick off. Just a couple of commands and you have a local broker running. And if you look at, this is what if you go to the web UI, localhost 8080, you can see this is what the UI looks like. This is a dashboard that gives you an idea of how many messages are passing through your broker, how many users you have connected to your broker as well. Okay, so then I have my service on Solace Cloud as well. So this is not localhost. This is this is a cloud instance. It's a managed service by Solace. So I don't have to manage anything here. I don't need to provide any infrastructure, and I can simply start a service in AWS. So this is what I have here, and I've connected these two brokers together already to form an event mesh. So you can see under the clustering, you can see that my local broker has been connecting to my AWS service to form an event mesh. Okay, then we also have the Try Me tab here, which provides you with a nice, very simple publisher and subscriber app. So I've connected to my subscriber app, and what I can do is I can show you that using topic subscriptions, and the wildcard greater than sign, I can subscribe to the market data that my feed handler is populating. So just to make sure that the data is actually going to our broker, let's subscribe to it. And as soon as I do that, you can see that, let's stop it. You can see that I'm getting my messages being sent to these topics, right? Okay, so the first part of our demo is working. The feed handler is publishing data to our broker. That is great. Okay, so the next part is to consume this data and generate some statistics on it. So let's do that. So first of all, let's connect on our local on my laptop. So if I run qrdb.q, I have this code already created. I'll show you what it looks like. I also have it documented. I have a blog post about it, and it's available on my GitHub repo as well. So if you were to run this code, you can see that I'm connecting to all of market data, so there's no filtering happening here, and I am connecting to my local broker, so no connection to my cloud instance whatsoever. And if I look at my underlying prices table, you can see that I'm getting data from all different exchanges, so NASDAQ, NYSE, LSE, SGX, and so forth. So there's no filtering happening over here, right? Okay, so let's exit out of it. And just to improved to, so this is increasing. Okay, so we're getting data. Then let's look at the code for it. So this is rdb.q, the process that I just showed you. What it does is initially it loads this sol_init.q file defined here. It basically has all this information about your Solace connection. So what host you're connecting to, port, your VPN, username, password, and some other settings. And that's pretty much it. So in rdb.q, what I also define is the topic that I would like to subscribe to. And you can see this is what had shown up earlier. So I'm subscribing to anything that falls under this hierarchy. This is great. I'm able to use wildcard provided by Solace so that I don't have to specify all the different topics that my feed handler is publishing data to, right? All I have to do is say, okay, everything that falls under this hierarchy, I should get data for that. Then I define the schema for my prices table, and I define a sub update. This is my callback function, and it is responsible for every time feed handler is pushing data to PubSub Plus. Anytime my broker receives a message, this function will be called, and what it does is it takes the payload and it basically parses it into a KDB row and inserts it into my global prices table. And that's pretty much all that's doing. Now what we would like to do is actually run our stats process so that we're not just capturing the raw data, but we are actually computing minutely stats on top of that raw data, right? So we're deriving some insights out of it. So very similar code. You're again loading the init file. One thing that's different is that I'm actually creating a queue here. So instead of just directly subscribing to the data from a topic, what I'm doing is I'm creating a queue and then mapping a topic to it. And what's interesting is that you can see that the topic structure is very similar to what I had before, but here I'm specifying the country, the region as well, so that I am not getting data for all the securities, but only the US domestic securities. This is a really powerful feature because it allows you to filter data dynamically. My queue process, my gen stats process is not going to be flooded with all this data from all the exchanges, all the regions, and then it's not up to me to filter that data within my process, right? I am getting the filtered data to begin with, which is a huge advantage, especially when you're working with hybrid clouds. So I'm creating this queue, mapping the topic to it. Again, I have my prices table being created. I'm doing similar stuff with my stats table, just defining my columns and their types. So I'm just doing highs and lows, nothing crazy going here, and VWAP as well. Then I have my callback function. Again, it's parsing my payload and inserting that data into prices table. What I also have now is my .z.ts function defined, which is on a timer to be kicked off every minute, 60,000 milliseconds, and it will run the update stats function, which is defined here. And all that's doing is that every minute it gets kicked off and it will generate statistics for you, right? And then insert that data into stats table. So we'll take a look at that soon. And once it does that, once it computes the statistics, what's great is that it takes data for each of those symbols, and for each symbol it generates a topic, basically a string of using this structure. So it says equity stats v1 and then appends the name of the symbol to that topic, and then when it publishes the data, it publishes it for each security, it publishes to a different topic specific to that security. And what that does is it will allow any downstream subscribers to filter on the symbol, right? So the more information you can provide in your topic, the better it is. So here I'm generating these dynamic topics and then publishing my data to these topics. Okay, so let's kick it off. So this is now I'm on my EC2 instance. So this is my EC2 instance running. I have KDB set up already over here. Before I was on my local instance, my laptop. Now I'm on my EC2 instance, and instead of rdb.q, I'm going to run my genstats.q. Again, the code for this is available online, so nothing to worry about. And when I create this, oh, I have my queue already created. So let me just clean something up. So I have this queue that I created earlier. Okay, so if I run this again, you'll see that this time I'm connected to my Solace cloud instances. It doesn't say localhost 55555. It provides you with the host name for my cloud instance. Then my VPN name is not default anymore. It's himanshu-demo-dev, and then my username and password. It also shows you that I'm creating a queue called market data, and I'm mapping this topic to that queue, which contains US level here. So we should only be getting US data being sent to this queue. Okay, and that's pretty much it here. So again, it should be getting the raw price as well. So you can see the number of rows are increasing. Now every minute I should get my stats data as well. So if I look at my stats table right now, there's nothing in there because 1 minute hasn't passed, right? Okay, so now we just gotta wait a little bit to see whether we actually get stats published. Aha, okay, there we go. So we got data for 6 of our US securities. So Apple, Bank of America, Facebook, IBM, Intel, and ExxonMobil. So you see we have one record per US security only, and this is really important that we didn't get data for any other security but the US securities only. And then we were able to compute these stats, but then also we were able to publish it back from within the same queue process. So let's take a look at our broker here. So this is the market data queue that was created dynamically from the queue session. If we go here to the subscriber app on the cloud instance, you can see if we just subscribe to equity stats, we'll be notified when we get the next batch of data when another minute passes by. So again, this is super important that our feed handler is publishing data to our local broker deployed on my laptop, yet I'm able to link my local broker with my cloud instance, with my cloud service, and share that data, right? Then let's go to the next phase. I already have an Apache Beam data flow pipeline running on Google, on GCP. So this is what the pipeline looks like. It consists of 3 different components. The first one is responsible to connecting to a queue that already exists with topics mapped to it, and then consuming any data that comes into that queue. Second component basically takes that data, cleans it up maybe, and then converts it to GCP row format, BigQuery format. And then finally it writes those BigQuery rows into BigQuery table. So if we go back to over here, so you can see that the stats data is being published to our cloud broker. And you can see the Weave app over here for ExxonMobil, and similarly for Intel. Okay, so everything is working as expected. This is the queue that our Apache Beam pipeline will be consuming data for. So it's called stats, and it is subscribing to this same topic hierarchy to get all the stats that are being published. So as the pipeline is running, it's doing its job in real time. It's been running for almost 35 minutes now, 36 minutes now. This is what my BigQuery interface looks like, and if I run query so let's look at my table first. Okay, so I have a data set defined called KDB data, which has a table called stats. So if you look at the stats table, this is what the table schema looks like. It's very similar. It's exactly the same as what I had in my queue process for the stats table. And you can see you have VWAP and all these high-low prices and sizes. Okay, so if I run my query, select star, just give me everything. All right, you'll see this is what it looks like. Again, you're getting the data, you're getting the stats that your queue process is generating and publishing to your Solace cloud broker. So yeah, so again, important thing is that this is only being done for U.S. securities, nothing else. So going back to our architecture diagram, hopefully this all makes sense now. We were able to publish market data prices to the local PubSub Plus broker and link that to our cloud PubSub Plus broker, which is deployed in AWS and completely managed by Solace Cloud. So I didn't have to do anything. I didn't have to spin up a separate EC2 instance to deploy that broker myself. It was all done through Solace Cloud interface. Then I had a separate EC2 instance to host my queue application, and it consumes data from the cloud instance of the broker, not the local instance, and it only gets the US data. Then it computes minutely stats on that data and publishes that data back to different set of topics. Then I have my real-time pipeline running on Google Dataflow on GCP. Again, it's another managed service, and it is listening to a queue which is attracting all these stats that are coming in from the queue process, and it is writing that data in real time to my BigQuery, which is another managed service provided by GCP. So that's the overall flow. Hopefully you like that. The key features here again are that you're able to link your brokers and applications deployed in different environments together, and you're able to filter dynamically. And you're opening up your KDB stack to all these cloud native services that would have been much difficult without PubSub Plus broker, right? So you can easily integrate now to GCP or AWS services to basically liberate all the data that is in your KDB stack and open it up to all these new shiny processes and applications that are available now. You can get started with PubSub Plus broker for free, even in production. So this is what they have: 2 editions, standard edition and enterprise edition. You can easily deploy them using a Docker container, and the standard edition is free to use even in production, and it comes with almost all of the messaging functionalities. It supports DR, supports high availability, supports compression. One of the only limits is that it throttles the messages to 10,000 messages per second, which I've noticed that for several use cases more than enough. So you don't even have to buy the enterprise edition. You can just go with the standard edition for your use case. Yeah. So that's it, guys. Hopefully you liked this video and found it useful. Let me know what you thought. Thanks.